welcome back to my channel. Today we shall be learning how to implement a Sierpiński triangle in Python. So let's get started. My name is Ronnie Athaire and this actually follows the blog I wrote earlier on today. I'm going to leave the link in the description about this particular type of triangle, about this gasket. So if you want to know what this triangle actually is, you can read about that blog and then get to understand before maybe you even continue coding alongside with me. So here I've opened our main.py file, which is a default file in Trinket. Trinket.io is an online code editor that can help us do code on. So let's get started. So I would say for maybe turtle, we're going to import let's import everything and we try them out. For example, if we try it right and we put in here a value of 100, what would that do? To just rotate that around like that. What if we tried something, maybe if you turn to right, you move forward 100 maybe steps. Wow. What if we did something like this, left 100. Okay, this is being confused I think by this. Let's remove this first. So what it does, it moves forward 100, then it turns to left. What if we did actually backward, put in 100 also. Wow. If we did only backward, forward and backward, just moves and comes back. Wow. And there's something called also fill color. I like things which are looking nice. If we used maybe yellow, let's see what that would do. Yellow, we see a turtle actually changing to yellow. There's some other method called let's try something else. Let's try pen up. You don't want to see the pen. Wow, don't even see the handwriting. Then if we did HT, it would hide actually the turtle. You can't see anything, but it's actually running. So if you commented this out, there's another method actually called stamp that I'm going to use here. Let's say no, it doesn't take anything. See what it does? So stamp stamps, as the name suggests, it actually stamps that particular tattoo that we are using. For example, if we changed it, maybe if we changed the shape, we can also change the shape. Maybe it's something like a square. See what happens? Yes. So those are the main methods we shall be looking at here. And maybe there's also left that I've not done. I've used it. Maybe if we did maybe a for loop for I in range in order to draw something. So we maybe said 0 to 3, those are the sides. Then we move forward 100. Then we move maybe also move backward. Move also backward 100. Let's see what this does. Let's remove all these variables here. See what it does. So if we actually said also added left, move maybe 120. Let's see what it does. Wow. So we need actually a triangle. So from here we can tilt this square. Let me actually call it a triangle. We want a triangle. Let me be sure. Okay. So here maybe we want, let's make this straightforward. Let's try something here. Let's put here 40. Okay, it's a little bit straight, so you can put actually something like 30 maybe. Okay, that is straight, that is straight. So we see actually that we are good to go. There's another method. Is there another method we can try out? For now, maybe let's now wrap this under a function, because we're going to be using a recursive call function. So you can call it any name. I'm going to call main here, which will take in a size and then an order. So it's going to be kind of like a length of that particular triangles that we're going to be building. Then the order could be the number of times, it could be the depth of the recursive call, in other words. So if I did, if I put this under, if I put this under here, then I will call our function, which is going to take in maybe size of 100. We start maybe with 1. So that means our forward is going to be our size, and this is also going to be our size. So let's run this. Yeah, everything is still working fine. So here we're not calling it recursively. Now let's use actually our order. Let's see if since we're not using this, maybe this method for now, maybe let's use our, it's going to be like our control recursive logic. So we can say if order is actually equal to 0, if that recursive call reaches 0, that means we should stop. Yes, that means we should stop. Let's run now. Yes, perfect. So what if there's a method called actually stamp? If we called stamp in here, stamp, what it does, let me try out stamp here. Let me see if we run this. Okay, yes, because we're not passing in. Okay, let's now maybe else. Let's add the else statement, or else we shall do this. So we put this under here. Yes, perfect. So let's run. Okay, so since we're not calling this function recursively, that's why it's not being stamped. But we can come under here after, and then we call our function again. We shall reduce the size by 2. Then we also decrease our order. We shall be decreasing whatever number we put in here. We shall be decreasing it until it reaches 0. Then we stamp. So that's what basically is happening here. So if I clicked now on run, see, it's now happening. It's being stamped. So so far so good. What if under here we remove this? Okay, can leave this fill color there. Yes. Maybe what you can do, let's increase this order. So the function is called maybe 2 times, and you see what's happening. Wow, it's looking super nice and sweet. So from there we shall actually build a Sierpiński triangle. What if now we put in 3? Let's increase the speed. There's a method called speed actually. You can increase this speed maybe by 100. Wow. So far so good. We are close to what we are actually looking for, and because the Sierpiński triangle, let me just Google here the Sierpiński, how is the spelling? Sierpiński triangle. It's actually Sierpiński. Okay, it's actually looking something like, yes, something like this. This is our end goal. Yes, it should be looking something like this. So if you come back to our code editor, maybe let's also change that to red. You can use any color you want. Maybe increase this to 4. So the function is called 4 times. Let's see what it does. Wow, perfect. We have a triangle. This is the triangle we actually been wanting to do. That's it for this video now. And then maybe what you can do, you can maybe comment this so that we don't see those paintings and those written things. Yes, now looking super nice, super good, super dope. Wow, this is actually beautiful. I'm planning to mint NFTs particularly for the using Turtle, so I'll be doing NFTs which are like this. Thank you so much. The code is actually in the, I'm going to share, I can share this code, trinket, this trinket code, but there's also a GitHub repo I created for this particular code, and this is all written in my blog. Please read that blog if you really want to understand what is actually happening here. Thank you so much. Have a great one.